Good evening, everyone. Welcome to this masterclass on embedded C programming. I warmly welcome you to the session. Thanks for coming and thank you for your time. Firstly, I would like to welcome the early comers first. Abhay Singh, good evening. Graphic design, good evening. John Ram, good evening. Sandeep, good evening. Palanipan and Priyanka, My Lifestyle, Daniel, Dolly, Asta Verma, and Harshad, Smart Navan, and Nandan, Chandra Prakash, Ramesh, welcome. Kavya, welcome. Manoj Kumar, welcome. Prem Sagar, welcome. Krishna, welcome. Ashish, welcome. Panindra Kumar, welcome. Rajat Saini, welcome. Shanmukha, welcome. Bala, welcome. Satish Kumar, welcome. Balanandan, welcome. Ankur, welcome. Shakti, welcome. Ravichandra, welcome. Devendra Yadav, welcome. So, thank you. Thanks for coming. If I am audible, just type yes in the chat box. If I am not audible, just type no in the chat box. I'll go with the majority. If I am audible, just type yes in the chat box. If I am not audible, just type no in the chat box. I'm waiting for your chat. Okay. If I am audible, just type yes in the chat box. Thank you. Thank you, Prajwal. Thank you, Pratik. Thank you. If I'm audible, just type yes in the chat box. Okay. Thank you so much. Okay. So, why 30 days challenge? Okay. So, this program is for 30 days, and this coaching has both mindset as well as skill set. We dedicated one slide for mindset because we believe that for your success, 80% is mindset. Okay. So, 80% of our success is accountable for mindset. So we dedicated one slide for the mindset coaching and the remaining slides are for skill set. Okay. For any habit to form, it takes 30 days. You do any activity consistently for 30 days, it forms a habit. So we have kept this course for 30 days so that we want to develop self-learning as a habit for you on both mindset as well as on skill set. Okay. So that's what 30 days challenge. So what you will learn on this 30 days. Okay, so what you will learn on this day one is about introduction to IDE, introduction to embedded systems. Okay, introduction to embedded and setting the tone for the 30 days challenge. Today is the introduction session. On day two, we'll be learning about the data types and variables. Okay, and day three, we will be learning the address variables and storage classes. And day four, how to write your own functions. Okay, we will be learning how to create your own functions. And day 5 we'll be going through the microcontroller programming about how IDE works, like what is IDE and how IDE works. And day 6 about the build process and analyzing the embedded code. Okay, day 7 is about the floating point data and Scanf. And day 8 is about pointers, to write a sample code on pointers. And day 9 is about the operators. And day 10 is about the decision making loops like if loop and switch case statements. Okay, and day 11 is about bitwise operators. We'll be learning bitwise operators. And day 12 is about blinking LED, how to blink a LED on in 8051 as well as on STM32. We'll be using two microcontrollers as a target device. Okay, one is the 8051, the other is the STM32. So 8-bit microcontroller as well as 32-bit microcontroller. So we'll be writing the code for how to blink an LED. And day 13, we'll be covering up how to use bitwise shift operators. Okay, and day 14 is about loops, how to write a for loop, while loop. And day 15 is about type qualifier constant. And day 16 is about the pin read and optimization. Okay, and day 17, we'll be learning about the volatile type qualifier. And day 18 is about structures. We'll be learning about structures. And day 19, we'll be learning of bit field in embedded code. And day 20 is about keypad interfacing, how to interface a keypad to 8051 and STM32. Okay, we'll be writing the C code for how to interface a keypad. And day 21, we'll be learning about arrays. And day 22 is all about strings. And 23 is about preprocessor directive in C. And day 24 is about the LCD programming, how to write a LCD program in C language. Okay, on 8051 as well as STM32. We'll be using Kale as well as STM32 QBIDE. And day 25 is about UART programming. Okay, 26 is about SPI protocol, how to write a code for TFT interface with STM32. And day 27 is about I2C memory program, how to write a code for I2C protocol. And day 28 is about how to write SPI ADC programming. Okay. Day 29, we'll be going through the interview questions in embedded C, and day 30 is about the graduation day. So we'll be issuing the certificates on day 30. Okay. So these are the things which we are going to learn for the next 30 days. Okay. So I hope you'll have a great learning on this 30 days. I will never waste your time. So we will have a WhatsApp, we will have a Telegram group for conversation as well as the Facebook group for conversation. So if you have any doubts on the sessions, you please post it on the Facebook group as well as Telegram group. I'll go through your chats and I'll go through your comments and I'll try to reply as much as possible. Okay. So are you ready to learn? Just type RTL in the chat box. Are you ready to learn? Just type RTL in the chat box. Ready to learn? Just type RTL in the chat box. Okay. So I'm waiting for a chat. I'm waiting for a chat. Are you ready to learn? Just type RTL in the chat box. Okay. Thank you, Joel, Lokesh, and Rohit. Thank you. Thank you so much. Okay. Ravi Teja, thank you. And Vinay, thank you. And Deepak, thank you. Okay. Krishna, thank you. And Subbareddy, thank you. Okay. So I'll give a short introduction about Pantech for 2 minutes and about me, and then we can go for the session. Okay. So Pantech, we basically manufacture microcontroller boards, DSP boards, and FPGA boards. We do also manufacture a lot of trainer kits for electronics as well as for electrical engineering. To know more about our products and services, you could visit our website pantecsolutions.net. So we have around like 42 microcontroller development boards. In 8051, we have 3 types of boards like evaluation board, development board, and advanced development board. In MSP 430, we have a development board, and we have development boards on PIC microcontroller and DSP microcontroller and PSOC. Okay, so we have a lot of development boards on FPGAs and DSPs. And our vision is to help 10 million students to learn the technology in an easy way. So far in YouTube, we have trained 2 lakh plus students on YouTube, and we have received 11,000 Google reviews on Google Review. So this year, we have a target of training around 8 lakh plus students within this December to train 8 lakh plus students on YouTube. This 30-day session is free on YouTube. Okay. So we have a lot of upcoming programs. We have upcoming programs on artificial intelligence, machine learning, a self-driving car, and robotics. Okay, so you please stay connected on our channel. If you have not subscribed, please do subscribe to the channel so that you will get notifications. You'll also get an email, but sometimes email will land up in spam. So you please subscribe to the channel so that you get the notifications. Okay. About me, my name is MK Jeevarajan. I completed my master's in the year 2002 from Government College of Engineering, Bagu, and my master's from College of Engineering, Guindy in 2004. I have around 18 plus years of experience on board designing. Okay, so I am responsible for the research and development team in Pantech. Okay. We have brought 300 plus in-house manufactured products. Like we have products on 8051, PIC, AVR, ARM. Just go through our website. Okay, so my primary expertise is on microcontrollers, DSPs, and FPGAs. I have worked on Texas Instruments DSPs and analog devices DSPs like Shock processor and Blackfin processors. On FPGA, I have worked on Cyclone and Vertex and Zinc and Spartan series. Okay, so this program is about sharing my knowledge with you. So we have conducted a lot of programs previously on embedded system design, and we have conducted programs on IoT, on MATLAB 30 days. Okay, so this session is about sharing my knowledge with you. If you want to connect with me, I'll share my LinkedIn link in the chat box. You could give me a connection request. I'm happy to connect and happy to help. Okay, just give me a moment. I'll share the link on the chat box. Okay. So I'll pin this. Okay. So I have shared my link. Okay, just give me a moment. Let me pin the link. Okay. Okay, so they will, okay, so you could connect me on LinkedIn. I'm happy to connect and happy to help. Okay, so coming to the announcement, the attendance link will be available at any time between the sessions. Okay, so we usually like we'll be putting the link at attendance link at 9 o'clock. So people do come at that particular time and they put the attendance and they go. The objective is to learn. It's not to get the certificate. Okay, so that's why we have put the attendance link at any point of time in the sessions, and it will be closed after 30 minutes of the session. Okay, so today the first 3 days we will be liberal, like we will be giving we'll be allocating more people. You could refer to your friends to attend. So the first 3 days will be liberal, like the attendance link will be extended for 12 hours, but after 3 days the attendance link will be valid only 15 to 20 minutes after the session. Okay, because we want you to learn. It's not for certificates, it's the learning which is going to bring money. Okay, so minimum attendance required to get a free e-certificate is 25 days. You need a minimum attendance of 25 days. So attendance for internship candidates, no need to fill the attendance form. All you have to do is, after watching the video on the portal, you just give complete and continue on the top, so that will mark the attendance. Okay, so once you complete the course on the internship portal, the certificate will be auto generated inside the portal itself. So no need to fill that attendance form. You could watch the videos at any point of time. Videos on YouTube will be removed after 3 days. Okay, so videos will be available only for 3 days and it will be removed after 3 days. So please do watch a video within 3 days if you want to refresh, or if you want to revisit any idea or any logic or like that. Okay, so for some classes we'll be using the recorded video streaming if I'm not able to present it on live, or if it is a lab class to improve the learning experience. Okay, so we'll be using the recorded video streaming on YouTube for some classes, or most of the classes. For the lab sessions it will be the recorded sessions, and PPT will be shared in the Facebook group and the Telegram group. Okay, and a PDF format. PPT is as a PDF format will be shared in the Facebook group and Telegram group. So if you have, we will have the Q&A session at the end of the session. But if you have any Q&A, or if you want anything to add, you could post it on the Facebook group. Your comments are welcome. So we want you to participate. So let us make this 30 days like great learning for you. Okay. So source codes and projects available only for the portal. It's available only on the portal. So for the source codes and project, but still, on going through this video, you should be able to replica the code. I assure you that this is not this session. This 30 days will be very, very useful for you. Like if you start the basic as an embedded system design engineer. Okay, and let's go for the mindset lesson for the day. Okay, so mindset, to come into the mindset lesson today. So today's lesson is about having a definite goal. Okay, decide exactly what you want. Okay, I got this line from my mentor Bob Proctor. Okay, so you should have a definite goal, and this goal should have a deadline. Okay, goal without a deadline is a dream. So first, decide exactly what you want. You want to be in business, or you want to be in job, or you want to earn money, you want to earn passive income, or what is it you exactly want. You decide that first. Once you decide that, you put it on the words on a paper. Okay, on a spiral bending notebook, on a daily basis. Okay, you write the goals at least twice a day until it gets into your subconscious mind, before you go to the bed and after you wake up from the bed, on the morning, early morning, and before the night. You have to write the goals so that your brain will communicate to the hand through the neurons, and your eyes will see the goal, and it acts as a feedback mechanism, and it stores on the subconscious mind. Okay, so to know more about the power of subconscious mind, you could go through a book called by Joseph Murphy, The Power of Subconscious Mind. If you have not read this book, please go through this book at least once in a lifetime. Okay, so today mindset lesson is about having a definite goal, and I'll give you an audio at the end of the session called Strangest Secret in the World. Okay, so that audio is for 30 days. You please do watch the audio, and please comment what is that in the Facebook group. Okay, so I love the comments. I'll go through the comments, what you have learned on this audio, which has created a lot of millionaires in the United States. So I want you to go through the audio at least once, and please do give me a comment like what you have learned from this audio. Okay, so this is the mindset activity for today. Let's go for the session. So today we are going to cover up introduction to embedded C. For every 5 minutes, I'll go through a chat. Okay, in between, I'll not be able to go through a chat. For every 5 minutes, I'll go through a chat, and I will ask if you want me to repeat. Just type repeat in the chat box. If you're clear with the topic, just type clear in the chat box. I'll be asking whether to go or whether it is clear or repeat. If you're clear with the topic, just type clear in the chat box. If you want me to repeat the topic, I'll just repeat the topic. Okay. So let's begin the session. Is that clear? Just type yes in the chat box. Is that clear? If you're clear with the topic, and if you're clear with the topic, just type clear in the chat box. And like no need to type present in the chat box. So we will be providing the attendance link maybe at the end of the session. Okay. So please be patient. So and you can fill the attendance form. Okay, don't type present in the chat box and don't spam. I may miss your chats. Okay, I may miss your questions. So please don't do that. So let's go for the session. Okay, so introduction to embedded C. Okay, so what is embedded? Okay, what is the difference between a normal C language and embedded C language? Okay, so in order to understand that, I would like to define what is an embedded system. What is embedded? What is the term called embedded? Okay. An embedded system, it's a combination of both hardware and software. The hardware is a microprocessor or a microcontroller based hardware and software with some mechanical parts to perform a specific task. Okay, so that is called an embedded system. I just repeat, it is a combination of a microprocessor and microcontroller based hardware and software with some mechanical parts to perform a specific task. That is called an embedded system. Okay. Your personal computer is not an embedded system. It is a general purpose machines. Okay. Your printer is an embedded systems because it do only the specific task. Mouse is an embedded system. Refrigerator is an embedded system. Okay. So these are all the examples of embedded systems. And whatever the device which you used in home, most of the devices are embedded systems because it do only the specific task, electronic systems. So I just repeat to get the word embedded, it's a combination of microprocessor and microcontroller based hardware and software with some mechanical parts to perform a specific task. Okay, so that is an embedded system. So embedded C, you write the C language. So in order to understand what is embedded C, before like we need to understand what is a program. Okay, a program is a series of instructions that causes a computer or a microcontroller to perform a specific task. Okay, it's a series of instructions that causes a computer or microcontroller to perform a specific task. It may have a data and various memory locations on which the instructions work to perform a specific task. Okay, so that's a program. Okay, so if you write the C code for an embedded system, like there are some features which is not compatible with with the embedded platform. Okay, so it's slightly, the embedded C is slightly different than the normal C language. So we'll go how we will go into detail like how normal C program works and how an embedded C program works. Okay. So coming to the programming languages in embedded system, you have C, C++, Rust, assembly, Java, and Python. So C, C++ is the most widely used. If you take microcontrollers, the mostly widely used was C, C++. Whereas if you take microprocessors, the most widely used language was Python. Okay, so if you take Raspberry Pi, you use Python. Okay, if you take Jetson Nano, you use Python. Okay. Whereas the microcontroller or like you will be using C and C++ is dominated for microcontrollers. Okay, so these are the widely used programming languages in embedded system. So is that clear so far? Is that clear so far? Is that clear? The first 3 slides is clear. Like what is embedded system? Okay, what is a program, and what are all the different types of programming languages used for embedded system? Is that clear? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Okay, so you will get the attendance form at the end of the session. Okay, you will get the attendance form. No need to worry about this. You will get the attendance form at the end of the session. And is that clear? Is that clear? The basics of embedded system design. Just type clear in the chat box. I'll go with the majority. Okay. So thank you so much. Ganesh, Shavita, thank you. Vishal, thank you. Ravindra Kumar, thank you. Manoj, thank you. Ravi Teja, the chat is going fast. Okay, so thank you so much. I see most of them is clear. Okay, so let's go for the types of processors and controllers. Okay, you have microprocessors, and you have I will go slow. You have microprocessors in the market and microcontrollers in the market. In microcontrollers, you have 8-bit microcontroller, which can do 8-bit mathematical calculations, which can store the 8-bit value. Okay, the data is 8-bit, and 16-bit, the data is 16-bit, which could do 16-bit mathematical calculation, and 32-bit. Okay, so and you have DSP processors like Blackfin is a DSP processor, Shark is a DSP processor, and you have Texas DSP. You have DSP processors in the market, and you have CPLDs and FPGAs. Okay, complex programmable logical devices and field programmable gate arrays. Okay, and then you have general purpose processor like AMD processor, Pentium 4, and GPU, NVIDIA GPU, graphic processing unit. Okay, so before that, GPU was used for gaming applications as well as for rendering applications, but today GPU is used for training, for deep learning applications. Okay, and ASIC, you have application specific integrated circuits, and you have system on chip. These are the different types of processors. Only if you know the difference between these microprocessor and microcontroller, and a microcontroller and DSPs and CPLD and FPGA, like, and how the compiler works for various microprocessor microcontrollers, you will get much more detail. So I'm going to explain much more detail about the differences between a microprocessor and a microcontroller and DSP and FPGA and the ASIC and SOC. Okay, so there are a lot of manufacturers. So if you go for a site called digikey.in, okay, let me show you a site called digikey.in. Okay, and if I search for microcontrollers, so Digikey is a supplier website. Okay, if you search for microcontrollers, you could find out 79,086 different types of microcontrollers. Okay, you could find out 79,086 different kinds of microcontrollers. Okay, so these are all the manufacturers like Cypress, Dallas, Fairchild, Freescale. Okay, and they also have suppliers in between. And you have Motorola, Microchip, National Semiconductor, and NXP Semiconductors. Okay, and these are the Sharp Microelectronics, Silicon Labs, Texas Instruments, ST Microelectronics, Silicon Labs. Okay, these are all the different types of microcontrollers, and there are total number of 79,000 different types of different variant is there. Okay, 79,886 variant is there with different types of packages and different types of packages, different types of pins. Core size is 4-bit, 6-bit, 8-bit, 16-bit, 32-bit. Okay, 32 core, and speed. These are the speed on various speed, and these are all the on-chip peripherals. These are all the on-chip peripherals on the microcontrollers, and these are all the program memory size. Okay, so you could check on the site called digikey.in. Let me check for 8051 alone, like 80C51 alone. Let me apply the filter for 8051 alone. Let me check the variant. It has 661 different types of 8051 with various packages. Okay, you have PLCC package, DIP package, SOIC package. Okay, so in 8051, like they have 661 variants. Okay, so like DSP is dominated by Texas Instruments and Analog Devices, and CPLD and FPGA is dominated by Xilinx and Altera. Previously, Xilinx and Altera are separate companies, like different companies. Now, Altera has been like Intel has purchased, Altera has been acquired by Intel. Okay, and AMD acquired Xilinx. Okay, so Xilinx is now AMD and Altera is now Intel. Okay, so Intel again, they are the CPU manufacturers. Intel CPUs and Pentium 4, Intel and Pentium 4. And GPU, NVIDIA is the major role for the GPU manufacturers. You have application-specific integrated circuits. Okay, this MoviDS stick is an example for application-specific integrated circuits. I will cover you like what is application-specific in the next upcoming slide. And we have system on chip, which is used on your mobile phones. Like Snapdragon is an example for system on chip. Even Raspberry Pi, the chipset in the Raspberry Pi is an example for SoC, system on chip. Okay, so these are the types of microprocessors and controllers. Okay, now coming to the microprocessor, like microprocessor, everything is external. Okay, so microprocessor, everything is external, whereas microcontroller, like the program memory, the data memory, and the UART, like UART, and all these things are external. Okay, whereas in microcontroller, the program memory and data memory, the timers, the peripherals like UART and CAN and ADC and timers, all these are internal. Okay, so for this you need a printed circuit boards, whereas everything is on single chip. So microcontroller, everything is on single chip, whereas for this you need you need to design a printed circuit boards. Okay, one example for microprocessor is Raspberry Pi chip is an example for microprocessor. 8085, 8086 is an example for microprocessor. Okay, so coming to DSP processors, if you want to do a complex mathematics application, then you could go for a DSP processors. Okay, complex mathematical applications. Microcontroller cannot do a DSP applications. Like if you want to implement a image processing application or speech applications or audio applications, you could go for a DSP processor. You could write the program on C language, and DSP processor like supports hard real-time constraints. Okay, so hard real-time means your embedded system misses a deadline that may cause an havoc. So that is hard real-time. Okay, there are two kinds of real-time systems: hard real-time and soft real-time. So hard real-time, missing a deadline may cause an havoc, whereas soft real-time, missing a deadline may degrade the performance. So that's soft real-time. Okay, so DSP usually run applications with hard real-time constraints, and it can process infinite continuous data streams. It has special interfaces like PPA, parallel peripheral interface, which could handle infinite continuous data streams, like a stream from a camera or a stream from an audio device, okay, stream from a speech, so that DSP processor can process. So DSP has MAC capability, multiply and accumulate capability, and DSP processors are again microprocessors designed for efficient mathematical calculations. Okay, so that's the advantage of DSP. So microprocessor, everything is external. Microcontroller, everything is on chip. Microcontroller is used for control logic, whereas DSP processor is for algorithms. If you want to implement a complex mathematical stream. Okay. Okay. Am I connected now? Am I connected now? Am I audible? Just type yes in the chat box. Am I audible? Just type yes in the chat box. I don't know, like the problem with the stream suddenly got stopped. Am I connected? Am I connected? Just type yes in the chat box. Am I connected? Okay, thank you so much. So where I left out, like the basic features of DSP, whether I want to start with basic features of DSP or the previous slide, just type the basic features of DSP. Thank you, Naveen Kumar. Thank you, Shyam Mishra. Thank you. Okay, so let me. So shall I continue with basic features of DSP? Just type yes in hard real-time systems. Okay. So so let me check for the connections again. It's okay. Okay. So DSP digital signal processors can do complex mathematical calculations. Okay. Whenever you design an embedded systems, basically there are two types of embedded system. One is the hard real-time systems, and another is the soft real-time systems. One example for hard real-time system is a nuclear reactor, okay, or the aeronautics, like aerospace. So whenever the system misses a deadline that may cause an havoc. So that kind of system is called hard real-time, the patient monitoring system. Okay, so these are all hard real-time systems. Soft real-time systems, your mobile phone, like whenever if there is a degrade in the performance, like if the system misses a deadline, you'll get only the degrade the performance. Okay, that will degrade the performance. So that is called soft real-time systems. DSP processors can run applications with hard real-time constraints. Okay, it's meant for that. And DSP can process infinite continuous data streams. It means like you could interface a camera, real-time camera, and you could interface an audio mic, okay, so which can process a continuous data streams, okay, and it has MAC capability, multiply and accumulate on a single instruction cycle, whereas this MAC capability is not in microcontroller, okay. And DSP processors are, again, they are microprocessors which has special interfaces like to interface high-speed ADC and high-speed DACs, okay. So like parallel peripheral interface, and it can do a complex mathematical calculation. You have two kinds of DSP, fixed point DSP and floating point DSP. Floating point DSP can do a floating point mathematical calculations, okay. So is that clear? Is that clear? Like is that clear? The microcontroller, the difference between microprocessor, microcontroller, and the basic features of DSP. Is that clear? Just type clear in the chat box. Is that clear? Just type clear in the chat box. Akhil Raj, like definitely we'll be having programming. From tomorrow onwards, we'll be having the programming. Like I'll also give you the assignments, so you could do the assignments and you could submit the assignments on the group, Facebook groups. Okay, definitely this today is the introduction session, like where we will be covering the basic of embedded things, because like what are the types of microcontrollers and what are the different types of IDE which you could choose for programming the embedded devices. Okay, so from tomorrow onwards, it's the pure programming. We starts with we'll go through the basics. We'll cover up all the we'll cover up all the examples. I will also provide you the assignments, okay, assignments, and you could try on your own. Definitely, like this is not going to be the entire 30 days is not going to be a theoretical sessions. The introduction session will be to have some basement, to have some fundamentals getting we need to have some basics. So today will be a theoretical session, okay. So attendance will be at the end of the session, okay. Attendance will be at the end of the session. So coming to the CPLDs and FPGA, PPTs will be shared on the groups, on the Facebook group as well as on the Telegram group. Please don't worry, like PPT as a PDF format, it will be shared, okay. So difference between a complex programmable logical devices and FPGA. CPLDs are control path oriented. Wherever you use microcontroller, you could use CPLD. Okay, wherever you use a DSP processor, you can use FPGA, field programmable gate arrays, or data path oriented. You could implement algorithms and you could implement a complex mathematical calculation on FPGA, but still there is a difference between a microcontroller and CPLD. It is reconfigurable. Okay, CPLD is reconfigurable. It means like you can customize the device, you can customize that integrated circuits by using the hardware description language. Okay. It also, FPGA also supports C language. You could also write the C program for FPGA. Okay, if you want to design an embedded system design using FPGA, that is also possible. You could write, there's a toolkit that they have separate, Xilinx has separate IDE, integrated development environment, where you could write the C code for FPGAs. Okay, and you could implement your own embedded system designs. CPLD, you could customize. For example, you take 8051. 8051 has one UART. Okay, if you want two UARTs, you can go for a software serial port. So you could implement the UART through software serial port. If you need 4 UART in 8051, then it is not possible. Whereas in CPLD, if you want 10 UARTs parallelly, still you could have that. Okay, every pin, IO pin, you could customize on your own. If you want 2 I2C, if you want 10 SPI, you could customize. Okay, so that customization is there in CPLD. Okay, complex programmable logical devices. And field programmable gate arrays or data path oriented, like wherever you use a DSP processor, you could use an FPGA. Okay, so this is the CPLD architecture. There is no processor core on CPLD, like you have only the logic blocks. If you want to implement 8051 on CPLD, you could still implement 8051 on CPLD. Okay, logic blocks, IO blocks, clock routing and routing matrix. Whereas in FPGA, you have the DSP blocks, okay, which can do DSP processing, the multiplayers, and you have the processor core. The core is, there are two kinds of core in FPGA. One is the soft core, the other is the hard core. Soft core means the core is created by the embedded by the code, by the software. Okay, like the core, what I'm talking is the architecture. Like FPGA, Xilinx FPGA supports microblaze architecture. It's a 32-bit RISC architecture microprocessor. You could implement inside an FPGA. And PowerPC is a hardcore processor. It means the core is fabricated in the fab itself. In Xilinx company itself, they manufacture the core in the FPGA. That is hardcore processor. Okay, the soft core and the hardcore processor. It can support soft core as well as hard core. Soft core, you create the core by using the program, that is soft core. You may create 2 cores if you want a dual core. You may create a quad core. Okay, whereas the hard core, it is manufactured on the fab itself. Okay, so FPGA architecture supports DSP, and it has memories, multipliers, and DSP blocks. Okay, so Microblade is a soft core. Okay, so is that clear till this point? I'll go through your chat. Is that clear till this point? If you want anything, you please type on the chat. I will go through your chat box. Is that clear? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Is that clear? Is that clear? Just type. Vishwat, Salunke, thank you. And Abir, thank you. Shakshi, thank you. Srijit, thank you. Dhanashri, thank you. Shantosh, thank you. Paul, thank you. Ankit, thank you. Akhil Raj, I will give you one example for Proteus, like how to do that. Let me check, and we'll also include the Proteus. Okay. And Swapnil, thank you. Anish, thank you. Suraj, thank you. Okay. Rahul is asking for repeat, so repeat. See, I will tell you the difference between CPLDs and FPGA. Okay, CPLD, wherever you use a microcontroller, you can use CPLD. Okay, it's control path oriented. Wherever you use DSP processor, you can use FPGA. So I will tell you the difference between a DSP and a FPGA. DSP, is sequential. Okay, DSP is sequential, whereas FPGA, it supports parallel processing. Okay, so if you have a parallel algorithm and if you implement that on a DSP processor and an FPGA will be much more faster than the DSP. Okay, because for example, in this example, for completing 256 operations, it takes 256 clock cycles, whereas the DSP processor is sequential. Like it to complete. I'll just repeat. Okay, I'll just repeat the process. I'll just repeat. Okay. Okay. CPLD and FPGA. Okay. CPLD is control oriented. The difference between microcontroller and CPLD is microcontroller, you cannot customize the peripherals. Okay. For example, 8051, it has single UART. If you want 2 UARTs, then you could use any of the GPIO pins as software serial. You have to write the code on the software serial. For example, if your application needs 4 UART, okay, in that case, you cannot implement microcontroller. So you could, whereas in CPLD, you could do the same thing on CPLD. You could have 5 UARTs simultaneously. Okay, you could customize every IO pin according to your need. Okay, for example, you need SPI, 2 SPIs. You could customize 2 SPIs. It will have a large number of IO pins. Okay, so and you could customize that one. But CPLD cannot be used for complex mathematical processing. It cannot implement any DSP processing. Okay, whereas FPGA can implement a DSP processing, because FPGA, the architecture of FPGA has a core, whereas CPLD architecture, there is no core on CPLD architecture. There is no memories and there is no there is no core and there is no multiplayers. Sorry, sometimes CPLD has a non-volatile memory. CPLD architecture, they don't have multiplayers and they don't have the core. Whereas in FPGA, you have the core. Okay, you have the processor core. The core means that I'm telling you what is the core is the architecture. Okay, if for example, FPGA, like Xilinx FPGA, they supports a Microblade architecture, that is a 32-bit RISC microprocessor. Okay, and PowerPC is a 64-bit microprocessor. That is a hardcore processor, which is fabricated in the fab itself, in the company itself. You cannot do that. The manufacturer itself will put the core inside the circuits, integrated circuits. Okay, whereas in soft core, the soft core is created by the software. Okay, that is a soft core processor. Microblade is one example for soft core processor. So if you can implement DSP applications on FPGA, okay, DSP application on FPGA. So when you compare DSP and FPGA, DSP is sequential and to implement, if you have a parallel algorithm and you implement in DSP processor and if you implement in FPGA processor, DSP will take 256 clock cycles to complete the operations, okay, because it's sequential. Whereas FPGA, it can be implemented in parallel because the language itself will support parallelism. The hardware description language itself will support parallelism, and it can be implemented parallelly. So it could complete the 256 operations in one clock cycle. So when you check the performance, if you have a parallel algorithm, FPGA will be much more better than the DSP processor, okay, in terms of parallel processing. FPGA supports parallel processing. Okay, so when to use DSP and FPGA? Whenever you need a higher performance, and whenever you have a parallel algorithm, then you can go for FPGA. Instead of choosing the DSP processor, you could choose an FPGA. And whenever you want to customize the design, the tailor-made, the FPGA is tailor-made. You could customize according to your need. Okay, you can customize according to your need. That's FPGA. So, and another example is less board real estate. I'll show you one example for less board real estate. How you can reduce the chips when you design by using an FPGA, and you could reduce the cost. I'll show you one example in the upcoming slides. Okay, so this is the traditional embedded system design using a DSP processor. It uses a Texas DSP TMS320C6711 series. Okay, in this board, if you check, these are all the block diagram. Like you have the power supply, you have the audio codec, and you have the Ethernet MAC, you have SRAM, and you have SDRAM. Okay, and you have the UART and display controllers. So these are all the thing which is there. Okay, you have DSP and SRAMs, and this is SDRAM, audio codec here. Okay, and the LAN controller, interrupt controller, and power supply. So power supply components will dissipate more heat. So this power supply component you cannot incorporate inside the FPGA. An audio codec has analog signal processing. It has some analog ground inside on audio codec ICC. Okay, so that cannot, because FPGA is pure digital, so it cannot have this because it have EMI, and FPGA has high speed signals inside that. So you should not mix an analog signal to the digital signal. So you cannot keep this audio codec inside an FPGA. SRAMs and SDRAMs, they occupy more silicon area, so that cannot be incorporated inside the FPGA. The rest of the part can be incorporated in a single chip. Okay, that's an FPGA. That's an advantage of FPGA. You could remove all those parts, and everything can be incorporated inside an FPGA. Okay, so that is one advantage of FPGA. So you could reduce the number of components. You could reduce the chips. Okay, so then you could have the audio codec here, the power supply part here, the SRAM and SDRAM part here. You could reduce the number of chips. You reduce the complexity of the PCB design. Since everything is inside the FPGA, it gives you more accuracy and it is more reliable. Okay, so that's an advantage of FPGA, and it is reconfigurable. You could customize whenever you want. You could reprogram it and you could reconfigure it if you want. If you don't want anything, you can remove it. Okay, so that's an advantage of FPGA. Is this clear? Is this slide is clear? Just type clear in the chat box. How you could reduce the chips by using FPGA. Is that clear? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I'm waiting for your chat. Okay. Attendance will be available at the end of the session. Okay. Attendance will be available at the end of the session. Please don't spam. So if you want to repeat, just type repeat. Okay. If you want clear, so I'll go with the majority. So thank you so much. Okay. So then comes the system on chip. Having more than one core on a single package is called multicore processor. Most of the mobile phones are SoC, like system on chip. They have more than one core on a single package. Example of Snapdragon is an example. And there are a lot of, if you go through those mobile phone specifications, like you could find out the name of the SoC. Like in this example, like they have ISP, like give me a moment. Okay, you have the image signal processing unit, you have the neural processing unit, and you have the graphic processing unit, you have the digital signal processing, central processing unit, and you have the video encoder and decoder. Okay, so everything is on a single package. Having two or more independent processors on a single package. So that is called, it's a multi-core processor. Okay, multi-core processor. If you have same type of core, then it is symmetric multiprocessing. If the core is different, then it is asymmetric multiprocessing. Okay, I'll show you one example for asymmetric multiprocessing having different cores. Okay, so for example, you take TI OMAP processor, Open Multimedia Application Platform. That is an example for asymmetric multiprocessing. You have the ARM core, okay, but it can do embedded applications. It can do control applications. Sorry, entire thing is embedded. It can do control applications, whereas the DSP can do DSP applications. Like it can take care of the audio, camera, okay, and that the DSP will take care of. Okay, so you have two different cores. So you could have two different operating systems. Okay, since the core is different, you could port Windows CE on ARM 11 processor. You could port Linux on Texas TMS320C6 C5X series, and you could do parallel processing. Okay, since the code is different, like you could run one applications on ARM 11, and you could run another applications on Texas DSP. So everything is on a single chip. Like you have GPS, you have the LAN interface, you have Bluetooth, you have telecommunication chipset, and you have the audio codec, USB OTG, and display controllers like TFT, and you have the MMC card, SD card, and camera module, I2C module, battery controllers, and NAND flash and non-flash. Everything is on single chip. Okay, so that is an example for SoC, system on chip. You have Snapdragon, that is also an example for SoC. Okay, so coming to ASIC. So ISP stands for image signal. They aren't choosing like ISP stands for image signal processing. Okay, and how FPGA is different from ASICs. Okay, application specific integrated circuits, like the neural compute stick. The Intel neural compute stick is an example for ASIC, application specific integrated circuits, which will do only the specific task. Okay, which will do only the specific functions. So this is viable. This ASIC is viable only when you have large quantities. Okay, so if you give the HDL program to the Xilinx or the Altera, the chip manufacturer will manufacture the chip only for your program. So that is ASIC, application specific integrated circuits, and it is viable only when you have large quantities. Okay, so in our company, like we are using one ASIC which is used for the headset called BrainSense. Okay, tied up with a company called NeuroSky, which uses a TGM module, ThinkGear ASIC module. Okay, so that module performs only, it receives only the EEG signal and it gives you the packets. You cannot program that ICs. It just receives the signals from the electrode, EEG signal from the electrode, and it give you as a packets. Okay, so that performs only the specific task. So that is an example for ASIC. Okay. So okay, so ASIC is viable only when you go for large quantities. So we use ASIC on BrainSense. We partner with a company called NeuroSky, who manufacture EEG headset. Okay, EEG headset for brain computer interface. So that is an ASIC. So whenever you want to implement a simple door lock, a microcontroller applications. Okay, so you could choose a microcontroller. Microcontrollers you could get for 20 rupees, 40 rupees. 8-pin microcontroller you could get for 20 rupees. 8051 you could get for 40 rupees. The Nuvoton IC you could get for 40 rupees. Okay, so if you want to implement a simple sensor IoT applications, you could use microcontrollers. DSP processors, you get it for 500 rupees to 1000 rupees. System on chip you get for again 500 to 2000 rupees, and it needs some quantity. Okay, system on chip needs some quantity. ASIC is viable only when you have the quantity. Okay, otherwise it's not viable. And then comes the FPGA. If you check the pricing of FPGA on the digikey.in site, you can see the pricing even for 25 lakh rupees. One chip set with 25 lakh rupees, 17 lakh rupees, one chip cost, which is used for aerospace, which is used for satellite-based satellite applications. Okay, so it's for hard real-time system like a nuclear reactor and patient monitoring devices kind of thing. So which has more performance and higher cost. Okay, so coming to the comparison, is that clear? Is that clear? Just type clear in the chat box. Is that clear? Just type clear in the chat box. Somebody is posting happy birthday. Today is not my happy birthday. Like today is not my birthday. Okay. Is that clear? Else, okay. Okay, I'll go with the majority. I'm waiting for a chat. Is that if it is clear, just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I will repeat the topic. Okay. So it depends upon the context, what to use. You have to, based on the application, you have to choose. If your application involves speech, audio, you use DSP processor. Okay. And if it's a simple IoT applications or sensor applications, you go for microcontrollers. Okay, and if you're designing an application for mobile kind of applications, tablet kind of application, then you can use SoC, system on chip. Okay, and FPGA for high-end applications. So coming to the embedded development lifecycle, the first thing you have to choose the IDE, integrated development environment. Okay, which has the compiler, assembler, everything put together. So IDE stands for integrated development environment. The compiler, assembler, linker, and loader put together is called an IDE. Okay, where you will have an editor window and where you will be writing the code on the C language and compiling the code, comparing that to an object file, linking to that, linking to a linker that creates a hex file which you download to the microcontroller. Okay, so you may have a C code, simple C code, or your application may require of RTOS, real-time operating system, or any networking protocols like control area networks, or you might require any networking protocols, and Java support and the graphics supports. Okay, so these are all the software. On the hardware side, you'll be having the bringing up the board, like the schematic design, the layout design, and the PCB board design. Okay, that comes to the hardware board. And finally, you will be integrating both the hardware and the software, and you'll be testing for real-time data visualization, real-time system analysis, and execution tracing, and memory leak detection, and CPU profiling. Okay, you'll be testing the performance of the system, and finally you'll be debugging on the field. Okay, so this is the complete embedded development lifecycle. But this course is all about embedded C language, how to write the C program, and for the various peripherals, and how to develop device drivers. Okay, so we will be covering more on C language starting from basics. So these are the list of IDE available in the market. You have MPLAB IDE for microchip. There are a lot of manufacturers, microchip manufacturers, Texas Instruments. They use Code Composer Studio IDE. So most of the manufacturers, they have their own IDE. They also have the third-party developers. Okay, like Keil is a third-party developer. They don't manufacture ICs, but they develop softwares for the microcontrollers. Okay, they develop compilers for microcontrollers. Keil is a third-party. Microchip Studio is from the manufacturer. MPLAB IDE is from the manufacturer. Code Composer Studio is from the Texas Instruments. It is based on Eclipse, and Arduino is not manufacturing. They use the AVR microcontrollers. Arduino does not manufacture any chips, any microcontrollers. Arduino is an IDE, integrated development. Arduino is a company which manufacture development boards. They do not manufacture any chips, any microcontrollers, and it's an IDE which has a compiler. Like the advantage of Arduino is they have a lot of inbuilt programs. So you just call the inbuilt programs, call the functions, and you could implement straightly the applications. For UART, you just call a single line of code, and you could print it on UART. Okay, and Visual DSP for analog devices, and Xilinx SDK for if you want to develop C language on FPGA, you could use Xilinx SDK, software development kit. So these are all the different types of IDE. We will be using two IDEs. One is the STM32Cube IDE for our course. I'll be sending how to install this IDE and the Keil IDE. Okay, probably I will also try to put the Proteus on it. Okay, so STM32Cube IDE and we'll be using the Keil, and we'll be using the online GDP. Okay, the online compiler tool. So these are the three tools which you'll be using through this course. I will send you the installation video on the Facebook group as well as on the Telegram group. The video will be separate, so you just watch the video and please do install these softwares. so that you could try it on the system. Okay. So coming to the recap. Okay. So coming to the recap, definition of embedded system design. Okay. Coming to the recap of, we have caught up the definition of embedded system design and definition of a program and a list. Okay. Difference between a microprocessor. We have caught up difference between microprocessor, microcontroller, DSPs, FPGA, and SoC. And we have caught up the embedded development lifecycle and list of IDE. Okay. Is that clear? Is that clear so far? Is that clear so far? Okay. Is that clear so far? Okay. Thank you so much. Thank you so much for your time. Okay. So we also have internship, and where we have the internship certificate, so where we provide the recorded video access for 30 days. Okay. And you could recorded video access for 30 days. Okay. And where you could access the 180-day course access, and you could download the source codes, and you could learn and practice these projects. Okay. And you could download the materials. So this is valid for 750 rupees. So if you have purchased, like a lot of people have purchased for 999 rupees, for them your course will be updated. Like you will get the updated course. Okay. Updated version. So today, like the single internship cost will be 750 rupees. Okay. So if you need an internship certificate, if you want the recorded video access for 180 days, and you get access to the community learning portal, and you get access to the What is Way community, where you have a lot of free courses on that. Okay. Apart from this, on YouTube, we also have separate free courses for the paid users. I'll show you the community. Okay. So those are the hackathon sessions. Okay, so we have a 3 hours hackathon session on Saturdays, sometimes on Sundays. Okay, which is for the paid users. Okay, so IoT hackathon sessions starting from morning 9:30 a.m. to 12 a.m. Okay, hackathon on ESP32 and Microsoft Azure, on hackathon on PCBDESIGN. Okay, so that's for the paid users, so you could make use of it. Okay, so we also have a combo offer running for today, where we have embedded C programming for 30 days, and embedded system design and IoT masterclass for 30 days, and Internet of Things for masterclass for 30 days, where we cover up 8051 architecture for 5 days, and PIC architecture for 5 days, and ARM7 architecture for 5 days, and LPC 4088 architecture for 5 days, and Node MCU architecture for 5 days. Okay, so this is for 30 days. All this is for 30 days, embedded system design and IoT. And IoT masterclass for 30 days, we have basics of IoT, ThinkSpeak, AWS, and Microsoft Azure platform 5+ projects. Okay, that is for 30 days. So all this combined together, you'll get for 999 rupees. Okay, so where you have 90 days of video coaching lessons and Beacon live Q&A sessions, and you have the internship certificate for 90 days and 15+ projects. Okay, you could download the PPTs, you could download the source codes and everything, and you get access to the private community. Okay, so that's a advantage. You have 90 days of lessons. Okay, for 999 rupees. So today, like, we have one more offer. You also get the PCB design masterclass, where you could design your own microcontroller board, design your own 8051 microcontroller board, and starting from scratch, of like schematic design and layout design, which is based on CAD and Allegro. Okay, so all this course, embedded C programming, embedded system design and IoT masterclass, and Internet of Things masterclass, and PCB design masterclass, all this course is 999 rupees. It's available only for today and tomorrow. Okay, so this 4 course is available for today and tomorrow. So if you wish, you could enroll this offer and you could grab it. We also have the job guarantee bundle, like job assistance program, where we cover up like artificial intelligence, AI masterclass. We cover up data analytics for 30 days, AI masterclass for 30 days, data analytics for 30 days, machine learning for 30 days, deep learning for 30 days, and Python for 10 days, and computer vision for 10 days, and for we have R programming for 10 days, and embedded system design and IoT for 30 days, and IoT for 30 days, FPGA for 25 days, 27 days, and PCB design for 12 days. Okay, and Arduino masterclass for 30 days, and MATLAB masterclass for 30 days, Raspberry Pi masterclass for 30 days. And apart from this, we have the soft skills like LinkedIn mastery, how to promote yourself and on LinkedIn, and how to interview skills, and how to build your resume, and time management and leadership skills. Okay, all these are soft skills. So this package is available at 7,999. So totally 20 plus courses. It's not 19 courses, it is 20 courses. Okay, with job assistance, with the job guarantee within 1 year. Okay, so we give the guarantee for 1 year, for job guarantee for 1 year, where you have access to 300 plus projects. Okay, intensive hackathon live session and from scratch, and live session on every Saturday. Interview questions and job postings, and 20 internship certificates with 2-year validity. Okay, so this pricing is 7,999. So if you could enroll this offer. Thank you so much for your time. I will take your questions. Okay, Q&A sessions. I will take your questions. I'm available for Q&A. Please put your questions in the chat box. So every offer comes with the you have the refund policy for 7 days. If you don't like this, you could get the money back within 7 days. Okay. So Lakshmana Rao, like you could get the hardware. What we are going to use is STM32. I will send you the link on the Facebook group and the Telegram group. You could purchase, or you could use the low-cost microcontroller like 8051 microcontroller, which is available in the market for 600 rupees. You could also use that one. Okay. So attendance form, like please do share the attendance form. Just give me a moment. Let me share the attendance form. So let me check. This course is the basic. Okay. So the attendance link, it should be on the description. Just give me a moment. Let me check for the attendance form. So please post your questions here. Like let me go through. I'll take few questions and close the session. It is not necessary to buy the hardware, but you could develop on the software. Not necessary to buy the hardware. Okay, I will try to include the Proteus so that you could try it on Proteus itself. Santosh Prabhakar, what is softcore processing? Like softcore processor. Santosh Prabhakar, softcore processor means in FPGA, you could create the processor code by the software. Okay, there is a tool called Xilinx Platform Studio where you could configure the processor through the software. So that is called softcore processor. So the FPGA like will have only the fabric. So you create the processor code 32-bit processor. If you want a microblaze architecture, you could put the microblaze architecture inside the FPGA, and then you could write a C program for that code. So that is softcore processor. This answer is for Santosh Prabhakar. Examples of microcontroller, Pavit Singh Narang. Examples of microcontrollers and microprocessor 8085, 8086 a microprocessor, and Raspberry Pi is a microprocessor with SoC, and microcontrollers 8051 is a microcontroller. Okay. Uh, the course is Santosh, like the course will be on C, embedded C. Okay. MAC stands for multiply and accumulate. Uh, the Tanusmita Das, MAC stands for multiply and accumulate on a single instruction cycle. Okay. DSP has a capability of MAC. Okay, multiply and accumulate on a single instruction cycle. So for Tanusmita Das. So Harpreet Singh, like in this course, we are not covering up MATLAB, but MATLAB, if you could evaluate the algorithms fastly in MATLAB. That's the advantage. If you are doing some research or if you are building up a new product, if you want to reduce the design time, then you could use MATLAB. There are a lot of inbuilt functions like that. It's just like Arduino IDE. You have a lot of inbuilt functions. You could call those inbuilt functions and you could verify. It's a simulation tool. Basically, it's a simulation tool. You could verify whether it is working or not. And now they also have the cross compilers where you could directly port to the embedded devices. Okay, if you want to port the MATLAB program to the NVIDIA or Raspberry Pi, you could also do that. Or Arduino, you could directly do that. You could also directly port the MATLAB code to the FPGA. Okay, CPLD does not have a core. CPLD does not have a core. Okay. Yes, you could use Visual Studio. Yes, you could use. Ankit Tiwari, sir, in FPGA, memory is like the CPU registers, her or something else. Because of DSP format, then we also stored immediate instructions. I'm not getting your point, Ankit. I'm not getting your point. So, what is simulation software? Is any simulation software for microcontroller? You could Rishi, you could use the simulation software. That's not a problem. You could use the same IDE for simulation. I'll let you know on this. On the next class, tomorrow class. If the application has face recognition, voice assistance with voice cancellation techniques, you could use DSP processor or Raspberry Pi. That's a Raspberry Pi, again, it's a microprocessor, which can do complex applications. But face recognition kind of thing, you cannot do it on a 8051 microcontroller. You cannot do it on a PIC 8-bit microcontroller. It needs at least a DSP processor or any Cortex high-end Cortex device, ARM Cortex device can do that. This is for Taruni Jedi. Okay. I'm still eligible for embedded job as I did training on embedded. TechBits is asking like I'm 2014 passed out EC. I'm still eligible for embedded jobs as I did training on 851. If you believe you can do that, you can do that. TechBits, it's all about mindset. It's all about mindset. Okay, so you need a coaching on mindset. If you believe you can do that, then definitely you can do that. Okay. FPGA can be programmed using embedded C. Yes, Harish Kumar. Yes, you can. It is possible. But you need to there's a tool called Xilinx Platform Studio where you have to port the processor first. This answer is for Harish Kumar. First, you have to port the RISC architecture, and then you you can download. You could write the C program, and you could download the ELF file inside this FPGA. That is possible. Okay. Yes, Srinath, you could use online compiler. You will do that. Okay. For PIC, you could go with the MPLAB. Okay. We could also use online compiler. Okay. Vivek, let me check out, and you will get an email. Okay. I will give you all this download links. Okay. I will give you the download links for the softwares. You please download the software. I will also send you the video on the group. Just go through that, and you do the installation, and we could try it on the same. Okay. So no need to worry. Like I'll give you the link. So Somasekar is asking what exactly the difference between C and embedded C. See, actually, there are a lot of difference. Like, for example, I'll tell you like the data type. Okay, if you take an 8-bit microcontroller, so the data types in 8-bit microcontroller which can handle is different, whereas the normal C processing is different. Okay, so you have to configure all those things according to that 8-bit microcontroller. If it is a 16-bit microcontroller or the data is fixed point DSP and floating point DSP, it means the DSP processor can do only fixed point calculations. The floating point can handle floating point calculations. So whenever you write the code for the floating point DSP, then you have to declare the appropriate data type for that. So that knowledge is required for embedded C. Okay. So you have separate manuals for that, compiler manual, whatever the controller you choose. If you choose the DSP processor, this answer is for Somasekar. Okay. If you choose a DSP processor, you have the compiler version, compiler reference manual for that. For microcontroller, you have a separate, you have to go through the compiler manual first. The declarations of data types, okay, and what are all the functions it supports, and what are the functions it won't support. For example, in FPGA, use printf for the normal C program, whereas in FPGA they use xyl_printf, okay, xyl_printf for printing that to a UART serial port. Okay, so that is a slight difference. Okay, so that there will be and the header files like startup codes, you have to add some startup codes to the project file when you go for an embedded C language. So all these are different. We'll be going through the entire course. Okay, not a problem. CCS, yes. Nitish Kumar, like if you understand this answer is for Nitish Kumar. If you understand the basics, like everything is almost same. The using of the Code Composer Studio, using of the Visual DSP, using of the Kale compiler, okay, and using of the Xilinx Platform Studio or Xilinx SDK. So the basics are almost same. The compiler and the debug and the release, and so the terminologies are almost same. Okay, if you understand the terminologies, there will be a slight change on the tools. That's all. But you could the way you create the projects, the linker description, the linker, the way you write the linker script are almost similar. Okay, the concept is similar. So if you understand for one compiler thoroughly, you could easily migrate within 1 or 2 days. FPGA stands for Field Programmable Gate Arrays. Okay. So programming for what software we will be using for C programming in the what software? We will be using online GDP. Vivek Kumar will be using the online free tool, and we also use the Kale compiler. We'll be also using the STM32Cube. Okay, so we'll be using 3. I will be sending all those to the Facebook group as well as Telegram group. Please join the group. I'll be sending the link to download and how to install those software also. Okay. So the FPGA for the embedded system roadmap, somebody is asking for the embedded system roadmap. Let me check for the embedded system roadmap. Okay, so this is the roadmap for the embedded system design. Like we have, you learn the basics. Okay, you learn the basics of Python, C, MATLAB if you want, you could learn, or JavaScript. Okay, then you learn embedded C. You learn the basics of Arduino with the different types of sensors. Okay, and you learn embedded system design and IoT, like various architectures, 851 architecture, PIC architecture, ARM7, or any architectures. Not the same. You no need to follow the same thing, but you could learn different microcontrollers also. STM32, you could learn STM32 or anything. Okay, and embedded driver development, you learn embedded driver development. You learn FreeRTOS. Okay, you learn Raspberry Pi and FPGA. So all these are embedded. And Internet of Things, you learn ThinkSpeak, AWS IoT, and Microsoft Azure, and embedded AI to implement artificial intelligence on embedded processors. You could use Raspberry Pi, Jetson Nano, and Pink FPGAs. Okay. And board design, like you learn how to design 8051 boards and how to design Arduino board, FPGA board, how to design IoT board. And PCB design, like you learn ARCAD, Altium, and KiteCAD. Okay, so application wise, you could learn different applications. So this is the way we have scripted. You may choose your own thing. Okay, I just give an idea. Like if you learn all those things, definitely you'll be an embedded programmer. But you have to invest at least 3 months to 6 months of time dedicated for this. But once you learn, definitely like you could go more and more heights. Okay, more and more heights. The attendance form is there in the link. Arbin, like the attendance form is there it is there in the chat box or in the description. It is there in the chat box. Yes, I'll share you the mind map also. Okay, I'll share you the mind map also. So Somasekar, like there is no Linux based compilers as of now here. Okay, in this course I have not planned. Tejas is you're saying in SOC all type of things, DSP, GPU, etc. on the chip. So do chip means chip means a single integrated circuits. Okay, in a single chip, single package, you have the CPU, you have the DSP, you have the GPU, you have the ISP, everything on a single chip. Okay, Tejas, should be strong in embedded systems? Yes, you have to understand. Pramod Kumar, like I will explain how to set up the IDE. I will make up a video and I'll post it on the Facebook group. You just go through the video and follow the steps as shown in the video, and you could implement the same thing. Code for ADC. Do we need to create a code for ADC in FPGA or it is in hardcore? You have to create a code like ADC. Like first you have to port the processor inside, and you have to port the ADC. For example, if you're using Xilinx FPGA, you could use Xilinx Platform Studio to create the ADC. They have a lot of IP codes. IP codes are pre-written codes, HL codes. So you could make use of it, and you could port the ADC inside the FPGA, and you could write the C program. Okay. Is FPGA microcontroller? See, FPGA is not a microcontroller. They are gate arrays. Okay, gate arrays. If you want to implement a microcontroller inside an FPGA, you could still do that. If you want a DSP processor to implement inside an FPGA, you could also have a DSP processor. Okay, so you could customize. So that's the advantage of FPGA. Amarnath, like please tell job vacancy for embedded programming. See, if you learn embedded programming, so that's what we have session like soft skills for resume, interview skills, time management, leadership skills, LinkedIn mastery, personal branding, and communication skills. You need to market yourself. Okay, you have to develop the skills necessary for marketing. Develop a LinkedIn profile page, have a personal branded website, and try to attract the hashtags on your LinkedIn page. Okay, so if you do that, then definitely like if you showcase your strength on the market, definitely you will get a call. Okay, so in interview skills, like in resume building, like this is a course like where we teach like how to build your resume for ATS tracking systems so that your resume got selected, because most of the companies they use ATS tracking systems for filtering the resumes. So your resume should be able to get selected on this ATS tracking systems. Only then it will reach the HR. Okay, if you're not able to write the resume for ATS tracking systems, then even though if you have skill set, you will not be reaching the HRs. Okay, so that skills we teach on the resume building. Okay, so you have to promote yourself. There are a lot of jobs are available. Amarnath, there are a lot of jobs are available. Sean, like let me check, and I will inform my. You will get an email. Okay. what is the future? See, unless you have electronics, you'll have the programming, okay, embedded C programming, you have the embedded system design. IoT is going to be the features. IoT, Internet of Things, is going to be the features. The one which is controlling the Internet of Things is the microcontrollers and the DSP processors and the FPGAs. Okay, so definitely there is a future for this. We could also implement artificial intelligence on embedded devices. Okay, so thank you so much. Thank you so much for your time. See you in the next session tomorrow. Until then, bye bye. Take care. See you in the next session tomorrow. Until then, bye bye. Take care. Thank you so much.